Hello and welcome to Steps to Maths, and today in probability we're going to be looking at the fundamental principle of counting. For probability, this says that for a given sequence of events with a certain number of options at each stage, then the total possible number of outcomes or paths. So remember when you drew a tree, you were thinking of all the possible paths that you could have for all the different possible outcomes. So the total possible number of outcomes is the number of options in stage 1 multiplied by the number of options in stage 2 multiplied by the number of options in stage 3 multiplied by the number of options in stage 4, and so on and so on. Okay, let's look at an example. In this particular example, we have event 1 where your options are A, B, C, and D. We have event 2 where the options are W, L, D. These might represent something. We're not going to say for the moment. We're just going to say that they are different options in each case. Event 3, our available options are 1, 2, 3, 4, 5. So how many options do we have? We have 4 options here. We have 3 options here. We have 5 options here. And by the fundamental principle of counting, our total options will be 4 by 3 by 5 equals 60 possible outcomes. So we can see the number of outcomes increases rather rapidly because we're multiplying, and that'll become important along the way. So it might seem very straightforward. All you're doing is multiplying, and that's all you have to do in this question. But if you're interested, I'm going to explain why this kind of happens. Okay, so let's have a look at listing all the outcomes. Our first outcome is option A, the first option from the first event, followed by W, the first option from our second event, followed by the number 1, the first option on our third event. Instead of writing out A followed by W followed by 1, I'm going to shorten that to AW1. We do this a lot in maths. We don't like writing out lots of English. So AW1 means the first option A followed by the option W in the second event followed by 1 in the third event. That was our first outcome, AW1. Our second outcome is AW2, which means A, the first option in event 1, followed by W, the first option in event 2, followed by 2, the second option in event 3. So I'm very, very systematic about how I count all the possible paths. As you can see, I start with the first possible option in event 1, the first possible option in event 2, and the first possible option in event 3. In my second pass, I start as early as possible. I pick the first option as much as I can. So it's the first option A, followed by the first option W, followed by the second option 2, AW3, AW4, AW5. Once I've gone the first option A, the first option W, and the final option 5, I can now move on to the second step. So the question is, what's my second step going to be? Well, I stay as early as possible in my first option. It's going to be A. So I stay as early as possible in each case and then go through the final options at the end. So I'm still on the A's. I can still pick an A because I can now follow it by the L. I can have my first option, this outcome is picking the first option from event 1, the second option from event 2, and then again the first option from event 1. So I'm picking the earliest one in each list that I haven't already done. And it actually comes out quite easy. You'll see it's quite easy here. When I'm explaining it, I'm saying I'm picking the first option in each list that hasn't been used. And you'll see how it kind of works. It works like a combination lock. Imagine I had a combination lock and this had an ABCD. The second turning combination had WLD. The third combination turning had the numbers 1, 2, 3, 4, 5. So I leave these two here and I go 1, 2, 3, 4, 5. Now I go back to 1, but I've already done AW1. So now I tick this over from W to L. And I do the same, 1, 2, 3, 4, 5. Let's have a look. I've got AW 1, 2, 3, 4, 5, AL 1, 2, 3, 4, 5, AD 1, 2, 3, 4, 5. So you can see I'm going through all the options here and then switching to the next one, and going through all the options here, then switching to the next one. I'm going through all the options here And at this point, I'm back to W1. So then I pick B, the next option. Let's count how many we have. I have 5 options here with the W. I have another 5 with the L. I have another 5 with the D. So between this event and this event, I have 5 and 5 and 5. I have 5 times 3. I have 15 possible outcomes. And that's only with option 1. Only the first option from event 1. Sorry, this shouldn't say event. This should say event 1, event 2, event 3. So with just the first option from the first event, I have 15 possible outcomes. And of course, I have another 15 for the second, another 15 for the third, another 15 for the fourth, which will be a total of 60 possible outcomes. Now remember, when we're writing these out systematically, if you want to practice writing them out systematically, start with the earliest possible option in each event that you haven't used. When you get to the final event, then you can start going through all those options. Then go to the next earliest option in the previous event and work through those. So that's how you do it. That's how you'll work through it all. That is not what is required here at all. All we need to know is the fundamental principle counting is that the total number of possible outcomes, you just multiplied the number of options together. So today, I've introduced you to something. I've talked about why it happens. You're going to be using this information later when you want to write out full lists and when you want to create full trees and when you want to calculate full probabilities. You will be using this information. But today, you'll just be multiplying numbers. So have a go at that exercise. It's pretty straightforward, and best of luck.